Okay, so have you ever like looked at a rock and then like a rabbit
Hmm.
and wondered like what's the fundamental
Oh,
difference
yeah.
between those two? Besides, one hops around,
Mm.
what really makes one alive and the other not? Well, there's this really cool idea called assembly theory,
Uh-huh.
and it's basically like a no way to think about complexity in life. And it was developed by this guy Lee Cronin
Okay.
and his team over at the University of Glasgow.
Interesting.
So we're going to take a deep dive into that, and it uses this really cool analogy with Legos, which I think is going to help us understand
Love Legos.
how this whole thing works.
Okay, I'm excited.
So, to get started, the basic idea behind assembly theory is that it looks at how many steps it takes
Mm.
to build something from its most basic components. So, like,
Right.
imagine you've got a simple Lego brick. That's like your starting point.
Right.
But then you can use those same bricks to build something super complex, like the Millennium Falcon.
Oh, yeah, yeah.
Right. So assembly theory says that the difference between that single brick and the Millennium Falcon is the number of steps it took to assemble them.
So more steps, more
Sure.
complex.
Exactly. And that's where this idea of an assembly index comes in,
Okay.
or AI for short.
Got it.
And AI is basically a measure of the minimum number of steps required
Yeah.
to build something from those basic building blocks.
So a Lego brick would have a low AI,
Yeah.
and the Millennium Falcon would have a much higher one.
Exactly.
I bet.
And here's the really cool part. A higher AI doesn't just mean something is more complex. It also suggests that it's less likely to have just like randomly popped into existence.
No, that's interesting.
So like think about a sandcastle versus a sand pile.
Okay.
They're both made of sand, right?
Right.
But the sandcastle has a much higher AI because it takes a lot more specific steps to create that structure.
So you're saying that complexity itself
hmm
could be a clue to whether something was designed.
Yeah, that's one of the mind-blowing things about assembly theory. It's like it gives us a new way to look at the universe and potentially identify signs of life
Wow.
or even alien technology based on how complex something is.
That's amazing.
But okay, how do we even begin to calculate the AI for something as crazy complex as a living cell?
Right, that's a good question. So imagine this vast landscape, almost like a map, where
Yeah.
every single point represents a different arrangement of matter. We call this assembly space.
Okay, I'm picturing like a map with a ton of locations. Some are easy to get to, like
Yeah.
just down the road, but others are way harder to reach, like a remote mountain peak.
Exactly. That's a perfect analogy. Simple molecules that form naturally. They're like those easy-to-reach towns on the map. But the complex molecules found in living things, those are like those mountain peaks. They require very specific paths and conditions to form.
So life as we know it exists these really specific, hard to reach regions of assembly space, and it's creating structures that are incredibly unlikely to just appear out of nowhere.
Yeah, that's the idea. And that's what makes assembly theory so powerful. It gives us this whole new lens to view the universe through, and maybe even identify the fingerprints of life, even if it's totally different from what we're used to.
So we're not just talking about like finding little green men anymore. We're talking about looking for complexity itself as a sign of life.
Exactly.
That's incredible. So what are some of the implications of that? Like how does that actually change the game when we're looking for life out there?
Well, imagine sending a probe to another planet, but instead of just looking for water, it's scanning for objects with high assembly indices.
Wait, are we talking about like looking for alien megastructures or something?
It's definitely within the realm of possibility. We might find structures that we wouldn't even recognize as life based on our current understanding. But if they exhibit this high level of complexity, this high AI, assembly theory suggests, they might have been created by some kind of life process, even if it's totally foreign to us.
So we're not just looking for Earth-like biochemistry anymore. We're looking for complexity itself as a sign of life.
Exactly.
This is blowing my mind.
It's pretty amazing stuff.
Yeah. So we're saying we could find like alien cities or spaceships just by looking at how complex they are.
It might not be cities or spaceships as we picture them.
Yeah.
But the point is, assembly theory opens up this possibility of finding signs of life or even technology that we wouldn't recognize just based on what they're made of.
So it's like we've been so focused on finding the right ingredients, like water or methane, that we haven't been paying attention to the recipe itself. And the recipe is complexity.
Exactly. The way those molecules are arranged, how complex that arrangement is, that could be a much stronger indicator of life.
Okay, so instead of just looking for a planet with water, we should be looking for a planet
Sure.
with like a giant ice structure or some crazy complex molecule we've never even seen.
Exactly. And that's really just the beginning.
Okay, so what else can assembly theory do?
Well, let's bring it back down to Earth for a second. Think about the origins of life on our own planet. We still don't fully understand how life arose. From non-living matter.
Right, biogenesis.
Exactly. Assembly theory could provide some crucial insights there.
So how does assembly theory help us solve that puzzle?
Well, if we can figure out the specific steps that led to the formation of those first cells, we might finally understand how life began.
And could assembly theory help us distinguish between things that formed naturally
Yeah.
and things that maybe had a little help?
That's a great question. Remember that sandcastle analogy?
Yeah.
The same idea could apply to life itself.
So if we find a really complex molecule with a super high AI, that's basically a red flag.
It definitely suggests that something more than random chance was involved in its creation.
Okay, so we've got alien megastructures, the origins of life. What else is assembly theory shaking up?
Well, think about artificial intelligence.
Okay.
If we can understand how complex biological systems assemble, we might be able to use those same principles to build intelligent machines.
So we're not just talking about smarter computers, we're talking about creating a new form of life.
It's a real possibility.
Yeah.
But it also raises a lot of ethical questions.
It's a lot to think about. But okay, no theory is perfect. So what are some of the challenges with assembly theory?
One of the biggest challenges is calculating the assembly index for really complex systems. For simple molecules, it's pretty straightforward. But for something like a cell, with trillions of interacting parts, it gets incredibly difficult.
So it's like trying to figure out every possible way to build the Taj Mahal, starting with a single grain of sand.
Yeah, it's a good way to put it. The computational power you'd need is immense. But even with those challenges, the potential of assembly theory is huge.
It feels like we're on the verge of something big, like complexity itself is the key to understanding the universe. But let's zoom out for a second. What does this all mean for us as humans?
It reminds us that everything in the universe, from our bodies to the galaxies, are built from simple building blocks, assembled in very specific ways.
And it makes you think about the creative potential of complexity.
Yeah.
The universe isn't just random, it's creating these beautiful and intricate patterns.
Yeah, it's pretty amazing.
It's weird. You know, after learning about this stuff, I look at everything totally differently, like my coffee mug. It's suddenly this like miracle of engineering.
Right. It's amazing when you start to think about it. Like, how many steps did it take to make this simple coffee mug?
Yeah, it's like the universe is playing this giant Lego game, building and rebuilding more and more complex things.
And we're part of that game now.
Yeah, exactly. Like, think about technology. We started with simple tools. Now we have smartphones, self-driving cars, AI that can write poetry.
And all of that is getting more and more complex.
Yeah, it's crazy.
And it makes you wonder, if complexity is a sign of life, does that mean our creations are becoming more lifelike?
Whoa. Are we like creating a new form of life? Artificial life?
It's a possibility. And it raises a lot of big questions.
Yeah, like where do we draw the line between something that's alive and not alive?
It's a tough one. But it's not just technology either. Think about art, music, literature. All those things are creating complexity.
So assembly theory isn't just about like physical objects. It's about creativity itself.
Exactly. It's a new way to look at the world.
So as we wrap up this deep dive, what's the one thing you want listeners to remember?
I think the biggest takeaway is this. Complexity is more than just how intricate something is. It could be a sign of life, a clue to how the universe works. And it shows us the amazing creative potential out there.
It really is a new way of seeing things.
It is.
Well, thanks for taking this deep dive with me. It's been mind-blowing.
My pleasure.
We'll see you next time for another deep dive into the universe.